We're going to factor these first three problems here. Let's begin with the first one. 21a minus 7b. Now remember, factoring means rewriting some expression as a product. We want to rewrite this difference as a product. That's what factoring is. So here we go. Between 21 and 7, we're going to look for what's called the greatest common factor. That is the largest number that divides into 21 and 7 evenly. In this case, if you know your multiplication tables, the greatest common factor, or we'll refer to that as the GCF, happens to be 7. So we're going to write that down. Notice in the variable portion of each of the terms, we have different variables. We have a here and b, so we have nothing in common, or we have no common factor in this variable portion. So 7 happens to be the greatest common factor of these two terms. Now, by writing the 7 out front, we call that factoring out the greatest common factor. So we factored out the 7, and what we're going to do is we're going to ask ourselves 7 times what number will get us back to this 21a. Well, I'm sure you know that 7 times 3 is 21, and to get the a, just write the a next to the 3. So let's just make a little check. 7 times 3a is indeed 21a. Let's continue in the same fashion. 7 times what number will give me a negative 7b? Well, first of all, I see I need a negative sign, so I'll write that down. The 7 is taken care of, but what we need to write here is the b. Now, what's nice about factoring, first of all, make sure you have a product, which we do. We have 7 times 3a minus b. And what's nice about factoring is we can always check to make sure our work is correct. We check by reversing factoring, which is basically using the distributive property. 7 times 3a is 21a, and 7 times negative b is negative 7b. So we are correct in our factoring. Let's try another problem. This one's a bit more complex. We start out with 12a squared plus 16ab squared minus 12a squared b. Now, don't be afraid about finding the greatest common factor, or the GCF. We'll break it into pieces. Let's first of all identify the number that is the GCF. I've got 12, 16, and 12. You don't have to worry about the negative sign at this point. And a number that divides into 12 and 16 evenly, and the largest number that does that happens to be the number 4. So I'll write that down. 4 divides evenly into 12 and 16, and it's the largest number that does that. Now let's see if we have any common variables. My first term has an a squared. My second has just an a. So what do they have in common? Since this one only has one a, they have in common just a to the first power. I must check to see if my third term also has at least an a to the first power, which it does, so a becomes part of my GCF. Now, because the first term has no b term as the other two, b cannot be a part of the GCF. In order to be a GCF, you must be a part of all the terms involved. And in this case, we lose a b, or we don't have a b here, so b cannot be part of our GCF. So now our GCF then is 4a. To write this now as a product, what we're going to do is ask ourselves the questions as we did in this previous example. 4a times what gives me 12a squared? Well, how about 3? I need that to be an a squared, so I'm going to multiply by a. Let's just make a quick check here. 4a times 3a, 12a squared. So far, so good. Let's continue. 4a times what number gives me 16ab squared? Well, we know that 4 times 4 is 16. That takes care of the numerical portion. I've got the a that I need, but what I'm lacking out here is this b squared. So I'll put that b squared on the inside. Finally, with our last term there, 4 times what, or 4a times what gives me negative 12a squared b? Well, I need a negative 3 again because I have a negative 12 there. 4 times negative 3. I have an a, but I want to get an a squared, so I have an a that's missing. And also, I need a b, so I'm going to add that as well. Again, what's nice about factoring, first of all, check, do we have a product? Yes. We have 4a times this other expression here, so we have our product. We are factored, and we can check by distributing. 4a times 3a, 12a squared. 4a times 4b squared is certainly 16ab squared. And lastly, 4a times negative 3ab gives us negative 12a squared b. So we did it correctly. Let's look at our last example down here. Now, I know it looks a little bit complex, but don't worry, we'll go through it slowly as we did the previous two problems. Again, let's begin by looking for the greatest common factor of the numbers. Don't worry about the negative signs at this point. Just look at 18, 27, and 45. Can you think of a number that divides into 18, 27, and 45 evenly? Well, in this case, that happens to be 9. 9 is a factor of all three. In fact, it's the largest number that divides evenly into those three numbers. Now let's check the variable portion. I have in this first term an a to the third power, and remember, to be a part of the GCF, we must be in common, so that's good so far. We have an a cubed and an a, so in common we have an a to the first power. And since this has an a to the second power, all three terms have at least a to the first power. So a becomes a part of our GCF. I didn't mean to make that a look like a 9, so I'm going to shorten that a bit there. Now, let's look at the b portion. I've got b squared, b cubed, and b squared again. So all three of these terms have at least a b to the second power. So b to the second power becomes part of my GCF. Finally, I look at the c's. I have a c to the second, and a c to the second. So again, I recognize that all three terms have at least a c, so I'm going to add that as part of my GCF. Now that I've completed that work, finding the GCF, we're ready to write our expression in factored form. Let's check here. 9 times what gives me 18? 9 times 2. I have an a, I need an a cubed. So I'm going to have to multiply by a squared, because a times a squared gives me that a cubed. Now b squared took care of itself, so we don't have to worry about a b there. And notice c takes care of itself as well. We can do the check by distributing. 18, a cubed, b squared, c, everything matches. Let's continue. Minus, because I see I have a minus sign here, and I need to have a negative product. 9 times 3 is 27. I've got my a, that's taken care of. B squared, I need a b cubed, so I need one more b. So we'll add that in now. And I have a c, but I need a c squared, so I need one more c. We'll add it in there. Finally, let's see what we have down here at the end. It's going to be a negative because I need a negative product. We know that 9 times 5 is 45. I have one a. I need an a squared, so I'm going to have to multiply by a. I have a b squared. That's taken care of. That's great. And I have a c. I need a c squared, so I'm going to multiply by c. Again, I didn't mean to make that long. That's an a down at the end. So I have 9ab squared c times 2a squared minus 3bc minus 5ac. Again, one thing nice about these factoring problems, you can always check to make sure you're correct by using the distributive property. So let's check to make sure we're okay here. 9ab squared c times 2a squared gives us 18 a cubed b squared c. That checks. The second two together, 9 times negative 3, negative 27. A, that takes care of the a. b squared times b cubed, c times c squared. So far so good. And finally, with our last term, 9 times -5, -45. A times a squared, that works. B squared, that works. And c times c squared. So if you take the extra couple minutes it takes to check through these problems, you should be able to factor correctly. Let's take another look at factoring. Here we're going to factor a little bit of a different looking expression. First of all, you might be confused because when some students see the parentheses here, they think they're in factored form, but actually this is not. And the reason is because right here in the middle we have a plus sign. We have this first term added to the second term, and remember we said that factoring is writing as a product. So at this point we do not have a product, but we have a sum. So we have to factor it. In other words, we want to write this sum as a product. Now let me underline the two terms for you, so hopefully that will help you in your mind distinguish the two terms that are up here. We have this first term, 3 times a plus b, and our second term, x times a plus b. Now what we're going to look for here is a common factor, or what these two have in common. I hope it's obvious to you that each of these terms contains the expression a plus b. So that's going to be considered our common factor. So we'll write that a plus b out front. And then in the second set of parentheses, we have to ask ourselves, a plus b times what will give me back this first term? Well, what is it? It's a plus b times 3. 3 times a plus b, there it is, 3 times a plus b. Now we have to ask ourselves, a plus b times what will give me the second term here? Well, I see if I multiply by x, I have it. And notice that's positive x, so make it plus x as well. Notice what I've done is I've come from a sum of two expressions, and I've rewritten it as a product, and that's called being in factored form. Again, don't be fooled when you look at a problem and you see the parentheses. Some students believe that's already factored, but it's not, because we have a plus sign between the two terms making it a sum. We must rewrite this as a product as we did here.